All right, guys, so we've talked about standard form of a quadratic equation. We've talked about vertex form of a quadratic equation. And we've kind of, mentioned that these equations would lead you to a quadratic graph. And we remember that a quadratic graph is a parabola shape. And so a parabola is either open up like that, or sometimes parabolas will open down. Either way, you get this U-ed or bent shape. The other thing we talked about was when we looked at vertex form, we talked about that the H is the X value of your vertex and K is the Y value of your vertex. So then we said you could write, HK is the XY coordinates of your vertex. So if this were my parabola, I would look at the furthest point on the top or the furthest point on the bottom. We say it's the maximum or the minimum. The vertex is where your graph turns around, and it's going to have coordinates from the vertex form of the equation, H and K. So that's just kind of like a recap on what we've already learned today. Today we need to really look at, if I give you a certain equation in vertex form, what can you tell me about that graph? So for example, if I tell you that we have y equals 3 times x minus 2 squared plus 3, well, you already know that you could tell me that the vertex is 2, 3, right? Remember that the h always changes signs. So it's minus in the formula, so it's positive in the equation, or vice versa. But that's really all you know. You know there's a vertex, and you know that it's going to give you some shape. A lot of you figured out on the last assignment that we did, there was like a open-ended free response question, and it asked you, how do you know if the graph will open up or open down? And a lot of you Googled and found out that this A value controls whether the graph opens up or down. So if the A value is positive, so a positive A value gives you a graph that opens up. A negative A value gives you a graph that opens down. And some of you Googled that, and I think you understood what you wrote down. But most of you gave me some confidence so you understand that idea. So that's the only thing you know right now about that equation in comparison to its graph. Today we're going to take some of these ideas and we're going to kind of solidify them and make some real notes about them. And then you're going to do an activity in Desmos today that's really an investigation. So I'm going to give you just the blanket basics of what you need in these notes today. And then you're going to open this assignment and you're really just going to try. Everything you do today, there's no single right answer. Everybody could end up with something different, but the whole idea is that you are playing with the graphs and you're figuring out, do you need a wider graph? If you need a wider graph, how do you do that? Do I need a graph that's up higher? How do I do that? So you're really just going to play with how to change the equation to change the graph to what you want, okay? So here, let's just go for the basics. When you talk about changing, you can change the A value in this equation, you can change the H value, and you can change the K value. And when you change each of those values, that changes something different about the graph, okay? There are vertical changes and there are horizontal changes. Vertical changes are changes that happen up and down on the graph, right? Because vertical is up and down. Horizontal are changes that will move your graph left and right. So if you want the graph to move left, you're going to find this left. If you want the graph to move up, you're going to find this. If you want the graph to be steeper, you're going to look at these notes. Does that make sense? So I don't know why I just said, does that make sense? You guys can't talk back to me in this video. So let's keep going. But that's the idea. I'm going to give you just the blankets of just the generic how to move the graph in this way. And then today you're going to use these notes to ask yourself, what do I need to happen? So which letter do I need to change for that? Okay. So first, let's talk about up and down. Up and down both use K. So if I change the K value, that technically changes the Y value of my vertex. And if I change the Y value, I'm going to go up or I'm going to go down. So Changing the k will move the graph up or down depending on what you want. So if you have a plus k at the end, your graph is going to go up. And if you have a minus k at the end, your graph is going to go down because the y value is negative, okay? Left and right. Let's talk about left and right next. Left and right, we're going to look at h. Because left and right are the x values move left and right. So the h, it's going to move your vertex left and right. Now this happens opposite to what it seems it should. Because the formula has a minus in it, remember when you take the h out, it makes it positive. So what's kind of weird is if you see inside of the parentheses, you see x minus the h, your graph is going to go to the right, which should feel kind of opposite of what you would think, because normally when you subtract a number, you go left, but it's weird because the formula has the minus sign. So if you want to move further right, you're going to subtract a larger number. If you want to move to the left, you need to add numbers inside the parentheses, and that will move your graph to the left. So if you want to go up, you're going to look at k. If you want to go left, you're going to look at h. Okay? So let's say I give you a graph and I want you to change it up 5 places from where it was. Well, then you're going to add 5 to the end. This is going to make much more sense when you see it with some graphs. But like I said, you just need the basics. Okay, a reflection. A reflection happens with A. And most of you could kind of tell me that. So when we say we reflect over the x-axis, what we're really saying is that if I have a graph and this is the x-axis, let's say I have a quadratic that faces up. If I reflect that over the x-axis, it's kind of like I take my paper and fold it on the x-axis, and your reflection becomes this direction. So that's what we mean. When we reflect over the x, we want to fold it in half on the x-axis. Really, that just means that if your a is positive, so a positive value for a means your graph will face up. A negative value for a means your graph will face down. Kind of like most of you already told me before. Okay? Now, some extra vocabulary words. If my graph points up, we say that we can say it opens up, or we can say it's concave up. That word concave is a word that you normally would see in, like, I think of like a physics class. We talked about concave mirrors. But concave up is the same thing as saying that your quadratic will open up. It means that it will extend forever on the top. And that also means, here's another vocabulary word, that the vertex is a minimum because it's at the bottom of the graph, okay? Now, opposite to that, if I have a negative a value, so if my equation starts with a negative, then I'm going to have a graph that opens down. Or you might also see that it's concave down. In lower level mathematics, we say it opens down. In upper level mathematics, you'll start to talk about the concavity of things. More specifically, when you get to like calculus, graphs can change from concave up to concave down quickly. And that kind of helps you know some other things about it. So just having that concave vocabulary is kind of important. If we have a graph that is concave down or that opens down, it does not have a minimum point because it will continue going forever down, but it does have a maximum. So if your graph looks like that, you refer to the vertex as a maximum value. Some common questions you might see are, can a quadratic have a maximum and a minimum? Well, your answer is no, because it's either going to have a bottommost point or an uppermost point, but it can't have both, okay? All right, steepness. The steepness of your quadratic also refers to the a value because it's the multiplier. And if you multiply something in an equation, you're changing how steep it is. This is still a vertical change. So really, because it's vertical, we say that we have a vertical stretch or a vertical shrink? When you stretch a graph out, then you are making it look skinnier, because you're vertically taking it and stretching it out. I like to think of like silly putty. If you take silly putty in your hand and you stretch it up and down, it gets really tall and skinny. A vertical stretch happens with a greater A value. Well, that doesn't make sense. Sorry, that's backwards. If you are stretching your graph, your A value gets larger. So let's say a larger A value. So let's say I have a graph as an A value of 1, and I want to make it skinnier or more stretched out vertically, then I need the A value to be larger than 1. Okay, if you're going to shrink it, when you shrink vertically, it's kind of like, we also call it a compression, a vertical compression. Compress. And if you think about something compressing, I always think about like a tool that's going to squeeze something down. When you compress something, it has nowhere to go but out. So instead of skinny, this makes your graph really wide. And if you want to compress a graph, you're going to give it a smaller A value. Now, when we talk about larger A's and smaller A values, we're really talking about the absolute value of A. Okay? This doesn't matter. The stretch and shrink doesn't matter if it's negative or positive. Negative or positive affects which direction it opens. But stretch and shrink, we're just looking at the actual value. So if I have an A value that's -2 and an A value that's -3, well, -3 is going to be more of your vertical stretch because 3 is bigger than 2. So just think, when you think reflection, take into effect the positive or negative. When you think steepness, pretend that everything is positive, and then just think larger or smaller, okay? Okay, so that's really it. I need you to understand that this was not a lot of notes, and it maybe didn't make a whole lot of sense because I didn't show you any examples. But that's okay. I need you to have these notes out and available. And then really today you're just playing with the graphs. And the more you play with them, the more that these notes will start to make sense and you'll understand how to use these notes correctly. And the more you'll remember it. If I just give you 5 graphs right now, you won't necessarily remember that. But if I force you to play with the graphs and really change what happens if I change H to 3, and you watch what happens to the graph, you're going to remember that a whole lot more. So take these notes and then start the Desmos activity and talk to each other. Really, if you talk to each other today, it's going to make so much more sense. And you're just going to kind of throw out different ideas. Okay? Okay, that's it.